You ever have that feeling in an exam where you just know you got the answer right, but then you don't get full marks? Well, in this explainer, we're going to crack that code. We are taking a real GCSE physics question and using the official AQA mark scheme to show you exactly what the examiners are looking for. Let's turn those tricky questions into points in the bag.
Right, we're jumping into question 4 from a recent higher tier paper. It's all about static electricity and this thing, a Van de Graaff generator. This is one of those classic questions that always seems to pop up, so really getting how to answer it is absolutely key.
Okay, let's dive right in. The first part of the question gives us a classic scenario. A student touches the negatively charged dome of the generator. We've all seen the pictures, right?
Now, the very first thing you should notice is right there in the brackets, 3 marks. That's a huge clue. It tells you straight up that you need to make 3 clear, scientifically correct points to get all the credit. So what are those 3 magic points, according to the official mark scheme?
So check this out. These are the exact phrases from the mark scheme. This is so important. Point 1, electrons are transferred to the student. You can't just say charge, you've got to be specific, it's electrons. Point 2, her hair becomes negatively charged. You could also say something like, each strand of hair gets the same negative charge. And then, the big finale, point 3, like charges repel. That's the core physics principle that makes everything happen, pushing each hair away from the others and making them stand up. 3 precise points, 3 easy marks.
All right, so now that we've nailed static charge, the question shifts gears and moves on to electric fields. This is another one of those core concepts, so let's make sure we've got it down cold.
Question 4.2 is a 1-mark definition, but don't let that fool you. The mark scheme is super precise. To get this point, your answer has to tick 3 boxes. You have to mention a region or area, a charged object, and the fact that it experiences a force. Miss any one of those keywords and you don't get the mark. It's a perfect example of why knowing your definitions word for word is a game changer.
Okay, this next one is another quick 1-marker. The question is pretty straightforward. As you get further and further away from that charged dome, what happens to the electric field around it? Does it get stronger, weaker, stay the same? What do you think?
And the answer is just that simple. It decreases. For 1 mark, that is literally all you need to write. The field gets weaker. And that's a great exam tip right there. Don't waste time writing a whole paragraph for a 1-mark question. Just give them the answer and move on.
And here we go. We've hit the calculation question. This part is worth 4 marks, which is the most in this whole section, so it's super important we show our working clearly. A lot of people can trip up here, but if you just follow a clear process, you'll be totally fine.
So here's the scenario for question 4.4. You've got a spark that jumps from the dome to a conductor that's earthed nearby. They tell us how much energy was transferred and how much charge moved. Our job? Calculate the potential difference, which, is just another name for voltage.
First step in any calculation, and I can't stress this enough, is to list your variables and check the units. Okay, so energy is 0.60 joules. That's the standard unit, so we're good there. But look at the charge. It's 2.0 microcoulombs, and that's the trap. The very first mark on this scheme is just for converting this correctly into standard units, which is 2.0 times 10 to the power of minus 6 coulombs. It's such an easy mark to get, but it's also so easy to miss if you're rushing.
Okay, next up, we need the right tool for the job, the right formula. If you're ever blanking in an exam, remember you can look it up on your physics equations sheet. The one that connects energy, charge, and potential difference is E equals Q times V. It's always a good idea to just write the formula down first before you plug in a numbers in.
Now, we just substitute our values into that formula. This step is your safety net, because even if you mess up the final calculation on your calculator, showing the correct substitution can still get you a mark. So we've got 0.60 equals our converted charge times V. So we need to find V, which means we just need to rearrange the equation. A little bit of algebra, and we get that potential difference, V, is equal to the energy divided by the charge. Again, writing this step down clearly shows the examiner your thought process and helps you lock in those method marks. Finally, you pop that into your calculator, and boom, you get the answer, 300,000 volts. That is a massive potential difference. Now, fun fact, for this particular question, the mark scheme says a correct final answer with no working would actually get all 4 marks. But please don't rely on that. It is always safer to show your steps, just in case you make a tiny slip up with the calculator.
Okay, let's wrap things up with the final part of question 4. This last bit is a multiple choice question that brings us right back to the core concepts.
So yeah, it's a multiple choice question. You can think of a spark as electricity, basically fighting its way through the air. And the question is asking, which one of these things would make it easier for that spark to travel a longer distance?
And the correct answer is decreased electrical resistance of air. Think about it like this. Imagine trying to run through a swimming pool full of thick treacle. You wouldn't get very far, right? The resistance is too high. But if it was just water with less resistance, you can move much further. It's the exact same idea with electricity and air. If the air is less resistant, it's easier for the spark to travel, so it can jump a much greater distance.
So what's the big takeaway from all this? Well, getting full marks isn't just about knowing the physics, it's about knowing how to play the exam game. You've got to use the specific keywords the examiners are looking for. You have to know your definitions inside and out. Always, always show your working in calculations, especially those unit conversions. And remember to let the number of marks tell you how much detail to put in. It's about working smarter, not just harder.
You see, once you start breaking down a question and looking at it from the examiner's point of view, the path to full marks becomes so much clearer. And that's a skill you can use for any topic. So what exam question do you think we should break down next? Let us know. Hope that helped.